Hello, everyone, and welcome to today's lecture series from Ubisoft. My name is Katharina, my pronouns are she, her, and I will be your host again. We are streaming live from our Düsseldorf studio in Germany. And for those who don't know, the lecture series is an educational streaming series which dedicates each session to a certain game development topic. And also there will be a Q&A at the end, so if you have questions, drop them in the chat. But please, because we have a lively chat and I tend to oversee questions that come during the lecture, drop all your questions when we are opening the Q&A. And even if you drop some questions before, just repeat them afterwards so that they don't get lost. Today we are focusing on the topic of gameplay programming, and for that I have Thorsten Schmiedl with me, senior gameplay programmer at Düsseldorf, who will give you a very interesting insight into how gameplay programming is made at Ubisoft. And if you're ready, let's go.
Yeah, thanks, Katharina. Welcome, everyone, to this Ubisoft lecture series. So today's topic, like Katharina said, is gameplay programming. And without further ado, I say let's get started. So here's what we have. What is the plan for today? So there's a short summary of what we will tackle. There might be some questions in between where I try to involve the chat. So feel free to interact. Katharina will read it out from time to time. So I hope we have a good exchange and a good conversation here. But let's get started with a short introduction. And I think this is where it starts already with the interaction. So we know that there are a lot of gamers out there, a lot of students, a lot of professionals perhaps watching this stream. So I've been interested in understanding, who are you? So are you a student? Are you a professional game dev? Are you just randomly stumbled across this stream? Yeah, let us know, and we will see what the audience is today, basically. But let's get started. So that's me. My name is Thorsten. Like Karina said, I'm a senior gameplay programmer here at Ubisoft Düsseldorf. I joined in 2017. First, I joined in Ubisoft Mainz, where I worked on the title Anno 1800, which I hope most of you know. If not played, it's really a cool game. And then I joined Ubisoft Düsseldorf and worked on Avatar: Frontiers of Pandora, which released last year in December. And yeah, that's what I do today. But maybe we already have some comments. So, Katharina, who are we?
Yes. So we have some people who commented. So we have a student. Mm-hmm. We also have a person who randomly stumbled across the stream. A random game enjoyer stumbling by. A long-time Ubisoft fan interested in learning more and possibly creating games. And yeah, so I think we have a very mixed audience today. And we hope to entertain you all.
Yeah. I hope you all get something from that. So that's the idea of the talk. So let's quickly get over what is this series about today, or what is this lecture about today. So let's define the goal. Like we figured out, there are a lot of different people watching this. So I will try to start with something very general, which is, what is even programming? What is a programmer? And what is it not? And maybe you will see it's more than you might think. And also, many of you might be considered programmers, even though you wouldn't call it yourself a programmer. And then we go deeper and deeper and deeper into the topic. So we will talk about what is programming in game development really like, and what does it mean to be a game programmer. And we end with a very hands-on. This is a day in the life of a gameplay programmer. And what there won't be today is there won't be any code I show to you. So if you're looking for a mechanic to how to implement a certain feature of a game, I think that's not the value that we have here today, because there are many good tutorials out there that teach you the code and what to do. And I will also have some references later or at the end of the talk for you to understand how to program, how to do C++, and so on and so forth. Today, it's more about how is it in AAA development and how is it specifically for gameplay programmer. So yeah, that's what we have here today. And to start off, well, what is a programmer? And while that might seem to be a quite easy question to answer, it's actually not. Because when I ask around in non-tech studios or departments and ask our non-tech people, this is usually what they think of us. You know, it's like a bit of, we're a wizard, we do crazy stuff that nobody really knows how it's done. At the same time, we're also sometimes a bit weird, so that might happen. And while this is kind of a flattering like image they have of us, it's actually not the truth. What it mostly feels like for us is, I guess, a bit of this. So we are a bit trying to get everything together. Things should not break, and we try to just make everything possible that is asked from us. And it's sometimes, we just have the code and try to make things work and hope that not just another bug will pop up. But on a more serious note, of course, there's also something you could define a programmer with, and this is what I try to come up here. So a programmer is a translator between human logic and machine instructions. So there's a lot in that sentence. There's the translator part, the human logic part, and the machine instructions part. So what that means is any idea of logic, this is the human logic part, can be taken, and then it has to be transformed in some way that a machine can understand that, what I want from that machine. And if you take this as a basic definition, there's a lot more than just writing code to it. And here are some ways you can program, or that is programming. And it starts with something like visual scripting. So as soon as you opened your most favorite engine, there's probably a visual scripting editor. We do have this in Snowdrop. Snowdrop is heavily based on nodes and visual scripting, and pretty much everything there is described in nodes. And when you connect them, and when you have different elements of nodes come together, it's like a logical statement, and that's already programming, even though I did not write any code at all. The second thing that I want to focus on is writing the code. That's like more of the obvious idea. It's you open an IDE, you type in the code, you compile the code, you run it, and you try to fix the bug that comes with that. Or hopefully it just works, but that's like a 1 in a million. It never happens on the first try. That's also, of course, ways to program. And the third one, which is a bit unusual and something you would not immediately call programming, is something where you put logical statements together. Let's be that abstract. And that means like building a contraption in Minecraft with redstone, which I guess many of you already have done once, at least once. It can be quite complicated, and it kind of is a programming thing you do there. It's already, you have to bring this programming mindset. And this is what I want to focus on here, is that programming is more than just writing code. So now that we understood what really programming is about and what a programming can be, let's talk about programming in game development in specific. I made this little diagram here, so I might have to explain it. On the left, you see what you have the machine. On the right, you have the player. Machine means it's very low level, what we call in programming low level. So it's down to the machine instructions. It's something that is opposite from the player, because the player means that's what you see in the game. So what's directly visible, where you have clear understanding, this is happening. And we have different disciplines in programming that list on this scale, so to say. And I just want to give an overview over what those programming categories can be. So let's start with the first, which is the closest we have to machine, which is the engine programming. So if you are an engine programmer, that means you are very, very close to the machine. You are very into optimization. It's really, you don't develop the features. It's more like you try to optimize as much as you can and make it as fast as possible, and try to build the whole base for what the whole game is built on. So it's the closest you can probably get to machine code. Then we have tools programming. This is a bit of a tricky one because I was unsure where to list that. So tools programming, on the one hand, it's never visible usually for the player, because it's something where you build the tools that is then used, or which are then used for the team or by the team, and it's never really player facing. As a player, you would never see the tools that we use in-house. However, sometimes there are games where those tools are also visible to the player. Imagine a game where you have a level editor or like some kind of character creation tool. Those are also tools and very visible by the player, but here I mean development tools. Yeah, then there are 3 more categories. The graphics programming is pretty much right in the middle. This is where all you have your fancy lights and the fancy shading and whatnot. It's also very math heavy usually, but it's of course visible by the player, because lights, the light you have in the game, or the water you have in the game, stuff like that, that's all very visible. And now to the last 2 categories. It's AI programming and gameplay programming. They are very close to each other. However, AI programming might be a step farther away. AI means, and we're not talking about the generative AI stuff that everyone talks about. This is basically NPCs, anything that the player will not control usually. And gameplay programming on the other side is everything the player can do. So this would be your jumping action, your sword that you have to swing. Anything the player can do is gameplay programming. This is personally why I really enjoy gameplay programming, because it feels that I can directly control what is actually happening inside the game. It's for me really rewarding to see that I improve some kind of mechanic and it just feels better now. There are other programmers, of course, that really like to optimize and dig down into the language and the programming details. But yeah, gameplay programming and AI programming, those are very close and to the player and very visible. So that's what I want to focus on in the next few minutes. So let's talk about AI programming. That's a tricky one, because when you think about AI and NPCs, what does it mean? Usually you have some kind of behavior an NPC can do. So that's something that needs programming. But then you think about, okay, I want my player the NPC to move somewhere. So it has to have an action, like the move action. You have to go somewhere, or maybe you have to hit something or do anything. But that requires, on the other hand, it requires a pathfinding algorithm. So something where you can say, what is the best path from this spot to another spot? Do I use the stairs, or do I go around the building? What's faster? Once you have a path, you then have to say, how do I get there? So that's motion planning. Do I run? Do I walk? How do I run? How do I walk? Do I maybe crouch? This is motion planning. And it goes on and on and on, this kind of thinking. And this graph will just explode. And it's there to show you how complicated AI programming itself can be, or programming in general. So everything you see on screen right now is part of AI programming. And that is required to bring something to life for a modern AAA game. And I'm not even sure when this ends, but you see here that all of this requires at least one programmer on a big team to realize. And it's a lot of effort to make each of those elements be the best and really shine. So if you just take an NPC that walks from A to B, you now realize what elements are really needed to make everything of this happen. And that's quite impressive if you think about how many people are just involved in that kind of development. And I think this is the last slide. So here it is. This is the full picture, and yeah, that's AI programming in a nutshell. But let's talk about gameplay programming, because that's the main topic of today, and that's what I want to get into. And you see community action. So I now want to do something in the vibes of Twitch, which is Twitch-based programming. I called it, very creative. And I want you now, so we will see a video in just a few seconds, which is 2 minutes long, roughly. It's gameplay footage from Immortals Fenyx Rising. And you as a chat, I want you to now focus on what features and topics you see in that video require programming work. So don't just look at the pictures and enjoy the game. Try to have this game development view for once, and try to understand what elements of a game needs actually attention. So you saw an example for AI programming, so maybe now we can get something for gameplay programming. So now we'll be quiet for the next couple of minutes, and we'll see that, and I will read the chat while we're doing so. So enjoy this little clip of Immortal Fenyx Rising. All right, that was a short clip. There was a lot in there. And yeah, if there's something that you spotted where you think, oh, this has to be programmed. And I know this is a finished game. For reference, it was Immortals Phoenix Rising. It's a Ubisoft game. I think came out a couple of years ago. And I want to use that as an example on what it required to really make a game shine. So I have the chat with me, so I can take a look. And there's something like a health system. Yeah, pretty good. Exactly. This is where it starts, right? We have something that the player has to have health, and not just a player, but also the opponents. What else can there be? A navigation system, state and effect systems. Great. Those are perfect examples on what it takes to really bring this to life. It's not just one topic, but it's a whole group of things that have to be taken care of. All right, here are a few examples that I wanted to focus on, because those are I think the most famous ones and the most important ones. So let's get started. The camera. That's mostly overlooked if you just watch a video, but the camera is so essential for the gameplay experience of a game. So any game that is third person or even first person, it doesn't matter. It's part of the so-called 3 Cs, which is character controls and camera. And those are essential to get right for a game. And especially if you think about different games that have a very immersive experience, often the camera does really sell this whole immersion because it's done that good. And topics to consider for programming here are, for example, the camera movement and framing. So how does it move? What does it frame? Is it steered? Is the player hinted at certain things? There are camera shakes that have to be applied, maybe adapted to certain situations. And of course, one big topic for camera is the collision avoidance. So you always want the camera to be visible, the player to be visible, and the camera to not get stuck behind an object or something like that. And it's difficult in an environment where the player can usually do anything with a camera. So therefore, it's difficult to get this right. But yeah, it has to be programmed. Then there's, of course, what you see, the combat. And there's so much to it. Combat, of course, could be a whole unique talk about how to do combat in games. But there are, for example, something like combat markers you have to display. So indicators for the player to know what's going on. There's a lot of animation work going on. There are VFX. And of course, there's also the logic execution. So decrease the health of the enemy. Make them, I don't know, hurt. Bring them to hurt states, for example, if they got some damage. Then you might have games where you have weak spots. So you have to have different logic depending on the player hitting a weak spot or a regular spot. Things should be different, and everything of this has to be programmed, of course, in some way. And the third one that's also sometimes overlooked because it just feels like it's always there is the UI. Also there, it can be more easier programming, as in just display some statuses. Like in this case, the items, how many items do I have? But then you already see, yeah, but what about cooldowns? I also want to see that in the UI. Then I talked about the combat markers. If there's a little blink or shiny effect when someone hits you, that also has to be programmed, and you have to have the context data available of that game to show that. So you have to know where the enemy is and all of this to display that. That's all parts of gameplay programming. All right, let's move on to a different focus. So now that we talked a bit about what are the topics that we face, I now want to talk a bit about the pipeline of games and where our job as gameplay programmer fits in the game development pipeline. First and foremost, we have an own lecture about production that was already done, and it's visible inside the Ubisoft lecture series. So go there. It's probably much better at explaining how game development works than I do today. However, this is my short approach and summary, so to say, of how a game is developed. So we start with a vision, and that's usually creative director that just comes up with an idea and tries to work out what the game should feel like. Not really be, but more like feel like. Then we have a plan where we try to identify how long does it take, what do we want to do exactly, what is the scope, how many people do we need, etc., etc. That's all the pre-production. Then it gets more interesting. We come to the design phase, which means all the game designers usually work out the whole idea of the game. Every rule of the game should be written down somewhere. So you could say the game is complete on paper. It's already playable, but just on paper, it's not available as a game you can play. Then there's the implementation phase. So you have to write code, you have to create the art assets, the audio and whatnot. And after that is done, the game is hopefully playable. And from there, we really go into the release roadmap, which means we playtest the game, we try to make it as good as we can. Then we try to polish it. So as soon as we know what is really fun in the game, we try to get rid of any bug we still have. And this is a very crucial phase, especially for programmers. We try to iron out all the bugs we have in the game. We try to make it as smooth of an experience as possible. And as you know, there are games that come out with bugs, and that's unavoidable, basically. We try to test it as much as we can and try to build the systems as solid as we can. But as you might already have seen, gameplay programming or programming is a very complex topic. So there are always some errors that occur. But hopefully you finish, you iron out all the bugs you have, and then you release the game. Then millions of players will play it. It's very exciting for the team always to finally release that game and bring it to the people's hands. But yeah, that you will encounter probably a lot of feedback, a lot of new bugs you haven't seen, and this is when you go to live phase, which is the patching in the end, where then the game is patched again. It's iterated. Maybe some rules are changed, and this is the rough rundown on how a game development pipeline may look like. The question for us now is, as newly game programmers, where do we come into play here? And you might have guessed it, it's the implementation phase. So that is what we usually work most of the time on. Of course, we also work on the polishing part and also on the post-launch sometimes, but the heavy work is really done inside the implementation. And so now that we know what programming is like, we understood what gameplay programming means, we know where we have to fit into the game production pipeline, I would say it's time to get to work. So let's get to work. Let's see what is gameplay programming like. And I assume that, like I said, a lot of students might be out there that have experience with maybe indie development or smaller teams. But here I like to get an idea for you on how it's like to work on a bigger AAA game and what it takes to work in such a team. So let's get to work. And there we have to think about, as a gameplay programmer that I want to be, what are my responsibilities inside a team? And there are a few. The first is quite obvious. It's the implementation. I write code, I bring features to life through code. This is what is listed on the slide. And yeah, it's basically the idea of writing code. But there's way more to it. This is part of our responsibility than just the implementation. So the technical feasibility is a big topic. Game designers usually come to you with a whole variety of different ideas on what a game could be like. And they come up with ideas where you think, yeah, that would be great, but it's completely impossible to do with the current tech we have. And there we have to assess the limits and constraints that we have tech-wise that we might not be able to do yet. And especially also, it's our duty to come up with alternatives to make things happen. And that's a natural relationship there is between the game programming part and the game design part. But that's a big responsibility you have. Then there's the part of the communication. I will focus on the topic of communication quite a lot on the later slides, because it's very important also as a programmer. So here it's about understanding the feedback you get, report the progress you have, and also document your features that you build for others to understand. That's part of the job. And which is to me often the most fun part, is the innovation. Of course, it's also our job most of the time to come up with innovative tech. So technology that hasn't been done before, some tech that has not been seen in games this way. And it doesn't have to always to be the groundbreaking stuff the whole world talks about. It's more like maybe we have some very unique idea on how to set up NPCs. Or, for example, in Avatar, there was the flying that was very uniquely done. And those topics are very interesting to work on, of course. It's not most of the time you don't have the time to do this, but if you get to innovate, that's also where we are the drivers to make things happen. This gives you a rough overview of what are the responsibilities. I think also important for people that want to get into game dev is like, but how to? What tools do I have to learn? How can I get started? What are the things that you guys use that might be helpful for us in our daily work? And the easy part for programming is Visual Studio. So everyone who ever coded probably stumbled across Visual Studio. It's the go-to IDE. This means this is where we write the code. And also in big studios, it's still the number one thing to have. And it helps to be familiar. Then you have the engine. And for Ubisoft, that's Snowdrop. At least it was for Avatar, and also Star Wars Outlaws was a Snowdrop product. So this is the engine you work with. And as a programmer, you expand the engine, so you try to build new stuff for it. But also, of course, you have to use it to debug the tools, to just test out a few things. Very essential to understand how that works. And now we come to two topics that are more administrative, if that's a word, but I think so. It's more, it means Jira and Confluence are both tools that are used to either track bugs. That's for Jira. So Jira means we have to track bugs, we have tasks, and project planning is also done in there. And while I don't set up Jira and create all the tasks, it's usually my duty to understand the system, and on a daily basis, I work with those features. And for Confluence, it's documentation. So it's a big part of my programming job is also to write documentation, because the best tool can be out there. If nobody really knows how to use it or how it works or how to improve it, then this will be quite useless. So writing documentation, in this case Confluence, you can imagine it's you can think of it as some kind of wiki page that you create. This is also part of our job. And then there's communication, of course, for Microsoft Teams. There are other ways to communicate, but this is mostly used in our teams. We have Perforce as a version control tool. So version control might be, not everyone might be familiar with that term. What it means is every time you make a change to the project, so you build a feature, you fix a bug or anything like that, you change the game. And to keep track of all those changes, we use what's called version control. So we understand which version of the game, every new change to the game will cause a new version of the game, and we can keep track and roll back or just have different versions of the game available. That's done through Perforce. And then two more. Let's talk about Miro. So if you want to ever have a brainstorming session with someone or talk about features, this is like dynamic boards. This is Miro. It's often used. I think there are other tools as well out there, but that's the big one. And the last tool is a bit more of an interesting modern side. It's MS Copilot. So we do use, from time to time, we use text AI assistants. It's of course an interesting topic that arises right now in the industry on how to use generative AI for development and whatnot. And for code specifically, it's not there yet that it would be in any kind production ready. But it sometimes does help in things, in very basic questions. It can write code very quickly. There's also the way to optimize your code with text AI. So those are things that sometimes this is used for. And but of course, there's still, everyone tries to find out how to use it to the best means, this new tech. But it's part of the tool chain by now. All right, I will quickly drink something. Again, if you have any questions, in the end there will be a Q&A, so keep them in mind, and then I will happily answer them. For now, let's talk about, we get deeper and deeper into the everyday life of a programmer. We started really abstract, and now we're at a point where we think of, okay, we understood all this. I want to get working, and what is the milestone? What does the next milestone look like? How do we approach the next 2 weeks? And here's a bit of how it works. So usually you have some game design kickoff. So some game designer had an idea, wrote them down, and be like, hey, this is what we want to do. Everyone gets on board, and we try to commit to our goals. Those who worked with agile project management, they might be familiar with that. But that's how it works. We commit to goals, and we know what to do for the, let's say, next 2 weeks or next 4 weeks, and then we start going and get going. Then we have to estimate it. That's very difficult, but it's a big part of what you do as a programmer as well. It's asked like, we need this new jump mechanic, for example. How long does it take you to implement that? And you often be like, I have no clue, because that might be more complicated than I think. It might be easier than I think, but it's important to get your estimations somewhat right. And over time, you will get better with that. And sometimes a senior trait is to have the best estimations, because this is what you get with experience. But it's also part of the job again. Then we implement that. Hopefully everything works according to plan, and we just implement what we decided on, what we committed to do. And once we created documentation, again, it's also writing text sometimes to users, manuals or whatnot. And then we review with the team on if we succeeded on the goals we set. And hopefully most of the time that's the case, but there might be situations where something was more tricky to implement, and then we have to talk about this as well. And that's basically the whole cycle we go through on a weekly or like bi-weekly phase. This is why then we go back to the start, we iterate. So once the feature has been developed, we go back to the kickoff and be like, okay, now that we played it, we realized, hey, there are some things that I would like to have changed. Let's get back to the kickoff and do the whole chain again. And you do this over and over and over until finally you have something you're happy with and you could close, hopefully, the feature at some point. And now we are like on a daily basis. So this is the programmer. This is us, basically. We are the programmer, and you have always this back and forth with usually 1 or 2 people that are involved with what you do. In this case, we once again take our beloved game designer. So we have the creative person, right, that comes up with all the rules and ideas, and they bring the idea. And I don't mean here like this kickoff we talked about or the vision. It's more like one concrete feedback point. Like, we need to do this. The jump height need to be higher, or it needs to have a bit more acceleration here and there. And this is what they need, and they talk to us. We implement that. We try to come up with alternatives if we think that it is not possible, and we bring the tech and improvements back to them. And this is the cycle that we go through on a very daily basis. So expect this to be more or less what you face every day. So you get ideas, you develop them, and then you get back to the tech and improvement part. All right. Now that we really do learn a lot here, and I now want also you to do something again. So let's see how we distribute our workload, and on what you think now that you learned all of this, how much of what topic really makes a day in a programmer's life. Probably better would be a week, because obviously not a day is not split like that at any time, but a week is quite close. So you see now in the presentation there are 4 different categories. There's meetings and others. Others would be something like studio events, some things that have nothing to do with a project that are still going on in your job. Then there is searching for information. So I need to find something somewhere. Then there's communication to peers. And we talked about it's important to sync and talk to people. That's clearly part of the job. And then when they have the part of writing code. And I want you to now give us percentages, or think about percentages of how much a workday is made up of those topics. So for meetings and others, what is a good percentage that you think how much of a workday is actually spent with meetings and other activities? And again, others could be studio events, something like that. Feel free to type that in chat. In general, it's, I guess, more than people might think. We have someone saying 40%. That's obviously a lot. So meetings should be reduced. We have 20%. That's good. 20% already. Yeah. 10%. There you go. 25%. So yeah, there are a lot of good estimations. I think you kind of hit the average there quite nicely. So I gave it 25%. Keep in mind those numbers are not scientifically proven. They are more like my experience. So others might have different opinions about this, but this is how I usually think a day goes. So yeah, 25%. That's quite a lot, right? It's a fourth of your week, nearly a whole day of just meetings. I can tell you sometimes it's even more than that. Oh, sorry, I spoiled it already. Maybe no one saw it. Nobody saw it. Don't scroll back if that's possible. I don't think so. Anyway, the next thing is searching for information. So how much time do I actually spend without producing anything, but basically just looking through other documentations, looking through the code base, looking through APIs to understand what do I need to get the feature implemented that I'm currently work on. And there's 15%, there's 10%. I see. Okay, a lot of numbers coming in. Keep in mind that's also a chunk of work that is quite tedious sometimes, but still it's part of the job. 70%. That would be a lot. If I would be just searching for information 70% of the time, we should fix something. Anyway, there's 15%, 40%. Okay, let's maybe spoil it. And it's 15% here. It's not that much, but it's still a good portion of the day spent in looking through the API and whatnot. Okay, next topic. Communications to peers. Again, we said communication is key. How much of time would I probably spend on communications? Someone says 15% is not that high, to be honest. That's true. But it's still part of the job. And we will see later on. I will give more explanations to that. 10%, 20%, 30%. Someone even has more. We're not sure if that's a race here, but 30%, 25%. Yeah, you guys listen quite nicely. It's good. It's 15%. So it's also a lot. But I mean, also consider that meetings could be considered communication here. So this is for me only like I have to talk to someone outside a meeting. This is not sitting in a meeting and discussing the thing. It's more like, hey, my favorite colleague, I need something. What do you think about this? Can we do it this way? Stuff like that. And now the final question, and chat, I still want percentages because I'm not sure who can do the math here, but there's a big chunk left. So the remaining part is, you have guessed it, 45% is writing code. Someone says 40%. Well done. 45 gang. Anyway, 45% is when writing code. So most of the time, we still write code. That's great. But what the point here is, and why I wanted to show this graph or this pie chart, is less than half of the time is actually writing code, which might be confusing to some of you that are not that familiar with the AAA development. So most of the time, I do not write code, even though I'm a programmer, which might seem a bit crazy. There are many other responsibilities that I have to take care of in order to actually write the code and produce the new feature that I want to do. And also a big topic here, if you merge those two categories, meetings and communication, that's 40% of the time. And being a programmer implies that you have to also be a good communicative person. So that means you have to be able to understand issues that people have with the feature you build. And you have to be able to remember the very initial quote we have. You have to translate the design into machine instructions, basically. So that's an important part. And also, this is like something you can take away from that. If you think of programming as a way for you to isolate yourself from everyone, be like, I want to be that person in the room that sits in a room and just programs all day, not communicating to anyone, and this is my dream life, then programming in game dev is probably not the place, because it's different. You have to talk to the team, and it's a team effort that brings the game to life, and you cannot just sit around and be on your own all the time. So keep that in mind. Katarina.
A little note on the side, because people are starting to get worried in the chat.
Oh,
this
wow.
is, of course, only the distribution of the workload. A work day also consists of breaks, lunch break, coffee breaks, bathroom breaks. So don't
Yes.
worry, we are taking breaks.
Yes, that's more like the work that I do.
Yes.
And my day, like, yeah, you just summed it up very nicely. Don't be afraid, we do breaks, and I encourage everyone to do breaks. This is just when I work, this is how I work. But nothing is better than a good, I don't know, coffee conversation and getting to know your colleagues better and stuff like that. That's, of course, a big part as well. Okay, good. Thank you that you clarify that. You should not leave it like that. Okay, next. Meetings are crucial yet unpopular. Yeah, that's for the people that already might work in game dev or worked in a bigger team. Meetings can be frustrating, or meetings can be tedious. It's a topic that spans far wider than just programming, but it's important, especially in those large teams that we usually work in. Being in sync and understanding what is the common vision of a and goal of the team is very important. And this is usually only possible through talking to each other and aligning all the time. So keep that in mind, that even though sometimes they can be annoying, meetings are essential to to align each other and to really bring a game to life in the end. So we come more or less to the final part of this presentation. So we talked about what is programming. We talked about what are the aspects, what tools do we use, how does my day look like, including breaks. And now the question, of course, hopefully the question for many of you is how to become a programmer. So maybe people are interested now, like, hey, this is really cool, this is interesting, I want to do this programming. How to? Tell me. And this is this part, what this part is about. So how to become a programmer. Let's a bit recap on what is the profile of a programmer. So from all we learned, we can say that a successful programmer excels in writing code, communicates clearly, and combines logical thinking with problem-solving skills to tackle complex challenges. That's, I mean, should now be somewhat clear to everyone who followed along this course today. It's writing code, it's communication, it's problem-solving. All of this is part of being a programmer. And if that's what you want to become, the programmer, then this is what you should focus on. This is the skills you need to develop. And now let's get a bit more into really the hard skills that are required. And I want to open the discussion or give a statement about the topic of C++ versus C#. So for those who don't know, C++ and C# are both programming languages, so a way to write code and to express something that you want the machine to understand. And there are different ways, different engines using different languages. For the industry standards and for Snowdrop and for basically any other bigger production, C++ is the most important programming language to have. So if you think about what skills should I develop, and if you never program in C++, your chances, you reduce your chances by a lot. And I would say that without any C++ skills, it's impossible to work as a programmer in game dev. So this is essential. It's a difficult language to learn and nearly impossible to master, but it's what we use, and it will be used for the next years for sure. And yeah, get up your C++ skills. It doesn't mean you don't have to. You should skip C# completely. I think I started personally with C# and worked for years with that as my main language. But I think you should use it as a starting point to understand programming concepts. So usually the programming language doesn't matter at all that you write in. It's more of how do you structure your code, how do you set up certain code architecture, and to bring the feature to life. And this is where C# can be very useful. But keep in mind, ultimately, everything you do will be in C++. So that's the go-to language to learn. And I will give you also some further readings on C++ in particular. The next thing what you have to bring is the communication. I can't stress it enough because it's often overlooked. But if you realize I'm a great programmer, which means I'm a great coder, I can write code, but I don't really like to talk to people, that's the area to improve on. So challenge yourself in talking to others. Don't be shy to communicate problems early on, especially when starting out. I mean, we try to talk to students here, so especially in the first job you will have, is essential, that you don't shy away and be like, oh, I should know this, maybe I should not tell anybody. No, go ahead. The whole industry relies on sharing knowledge and helping each other. So it's very essential to communicate all the problems you have early on. Then try to make sure you understand what is required from someone that approaches you. Like if a game designer has an idea, make sure you not just be like, okay, I got it, I will implement it, but ask them, is that what you want? Is that exactly like that? Or do you want a different one? How do you want to set up this or that feature? And this will help you improve your communication skills overall. And the third thing is experience. Of course, it's a bit of this kind of vicious cycle where you say, I need experience. For experience, I need a job. For a job, I need experience. This is not what I mean here. It's nothing where you need a certain job. It's more like building a portfolio. That is usually the thing that is always said. But for programming, I often refer to it as if you want to build a programming portfolio, come up with small mechanics of a game you want to develop. Let that be a shooter game where you want to have a certain shooting mechanic, maybe a grappling hook you want to implement, or I don't know, like a building system like Anno where you want a factory game. Try to build small prototypes. They can look completely bad, like that. It doesn't matter, because the key here is to learn to build bigger systems, to iterate those systems. So you are not done when you build like one factory game. You realize there's a lot to iterate on. So learn that and maybe compile a portfolio of small projects that you worked on that you are proud of. And if you follow all those 3 steps, you should be very well set to become a programmer that is well suited to tackle the AAA environment. So this is a very last slide now. Those are the next steps that you can do to become a programmer and to move on also with your studies and afterwards. And also I will add some further reading. So the first thing, get involved with the game dev community. That's so essential. It's what you do already today. It's listening to those lectures like we do here, but also visit the communities that are out there. Let it be Discord chats or YouTube channels or whatnot. Get involved, understand what they do, try to do it yourself. Not just watch those, but try to replicate what you see. And this will really, really teach you a lot. And nowadays we live in 2024. Those things come mostly for free. Like this lecture right now is for free, and I hope it teaches you a lot. Then develop your portfolio. That's what I said in the very last point. Use all the knowledge that you acquired today and other skills, and make something on your own. Come up with a small idea and put it in a portfolio. This will help tremendously for your skill set to improve, but also it will increase your chances to land a job. And the most important point, of course, enjoy making games. So in the end, while there's a lot of stress that can be involved and programming can be very complicated, think of always, like if you're stuck somewhere, think, why am I doing this? I chose this job because I love games, and this is really, it's a fun process to do, and it can be so much fun. And I like you meant, like you saw in the first slides, I released a couple of games now, and every time it's incredible feeling to be able to say we did it, we shipped it, and now so many people out there play our games. So yeah, that never forget to enjoy the games as steps. So now two more additions to really hands-on tutorials of what to do next. So there's a CPPCon. It's the biggest C++ conference there is. It's held on a yearly basis. They also have a YouTube channel where they upload a lot of talks for free. Yes, the CPPCon, of course, the professional conference. I think it's in America usually, or in the USA. The ticket prices are like the industry standards. So, but yeah, take a look at the YouTube channel. You'll learn a lot, and from junior to senior to whoever in this industry, everyone benefits from those talks because they know what they do, and those talks are usually very interesting. And the other thing I really want to highlight and stress: read books, like good old-fashioned books. I know this might sound a bit old school, and we live in the age of YouTube and whatnot, all the platforms. But reading books is is still very, very essential. So Effective Modern C++ von Scott Myers is a book I highly recommend that is listed here with a picture. Then Clean Architecture teaches you on how to build solid programming systems. And there's a tour of C++ from the inventor of C++ himself, which teaches you the basics, but also a lot of good insights into the language, which should help you get started with C++ in the world. That's all I have for you today, and I hope you learned a lot. So all I'm left to say is thank you, and I hope you had a great time. We now have still plenty of time to take questions, and feel free to list your questions. Maybe you have them prepared, maybe not. If there was anything that you want to know, now's your chance. So thanks a lot.
Yes. Thanks a lot, Torsten, for this very interesting lecture on gameplay programming and how we do this at Ubisoft and for AAA games in general. Yes, so now is the time to drop all your questions in the chat. We have opened the Q&A. As I said before, if you have asked a question beforehand, please ask it again, because I lost it in this very vividly and lively chat. But one question that was asked a few times that I can directly answer is if there are VODs of this lecture and maybe also the others. And yes, there are. So they are available as VOD on Twitch for this lecture and the procedural generation lecture we had before. And on our website, bluebyte.ubisoft.com, you can also find the other lectures that we had on our other channel. It was a panel working in AAA, and then we had the before mentioned production lectures. So if you're interested in these topics, you can have a look there and then watch the VODs. And now let me have a look at the chat to see if we have questions.
I spotted a non-tech question, which is, can I have one of those Nix plushies? I think they are very, very limited, so we're very happy to have them. And I would also really like one, but I'm not sure they are available.
No, I'm not sure about that as well. But here's a question for you personally. How did you become a programmer?
Oh, that's, I mean, I played a lot of games in my youth, in my childhood. I mean, many of us did, and this, of course, was a high influence. I started out wanted to become a game tester. I always wanted to test games, but eventually I studied math after my high school, or like in Germany, that's the Abitur. After that, I studied math for 1 year and decided this is not it. This is not what I like, and then I quit it and started a game specific studies. And this is how I got into programming. I think if I think about what I said in the beginning with not just writing code as programming, then I probably programmed before that. So there was a lot of, I remember, for example, Warcraft 3 editor maps. I'm not sure if someone still remembers those, but you could set up different logical rules and have custom maps being made. I was really into that, and there I think I built my programming mindset in a way. So that's how I got into games. Yeah.
Oh, thank you. The next question is, to what degree are you bound to internal engines like Snowdrop or Anvil? And when can you use Unity, Unreal, Godot?
Yeah, that highly depends on the project. I'm not sure if we... usually we have our own in-house engines, which is, of course, a great benefit we have here. So like I mentioned, Snowdrop, then there's also Anvil for other projects. But Snowdrop is an amazing engine we have. It's really something where we can completely control the engine by ourselves, and you see it also with I think the games we ship. They usually look amazing, and therefore we are not bound by it technically, but it's better for us to work with them because we can clearly control them. So I'm happy we have this opportunity. For the third-party engines, I would say usually those are just for smaller projects. However, there might be also projects inside Ubisoft that use them. I'm not sure about that. Yeah.
Okay, thank you. Next, I appreciate the lecture. Thank you. And the question is a bachelor in computer science a good route?
Absolutely, that's a perfect start. It teaches you the fundamentals. For computer science, studies in general, make sure that you still keep the game focus. So often they teach a lot of very theory stuff about how a computer works and the physics behind them and whatnot. But also keep in mind that you would apply for a game development position, and that requires a bit different things like we talked about today that are also relevant. So, but it's a great start. It teaches you all the fundamentals. However, still the things apply that I said. And also to say this while we're on this topic with degrees, it's not necessary to have a degree in anything to be a good game developer. That also applies for a job. Of course, that gives you the fundamentals, but as you saw, those are the skills, and they are not just developed in studies, but they can also be learned and trained by yourself if you're willing to.
Okay, thank you. The next question is, can you learn C++ right away, or is it important to learn a different language first?
Both works, as you can learn C++ right away. It might have a higher learning curve, and it might look a bit more difficult. So we have, for example, programming languages like Python that are more descriptive. It's easier to understand at first glance what's going on. In C++, you often have a lot of what we call boilerplates, so things you have to write in order to make it work. That might be a bit more intimidating, but especially the tour of C++ that I listed really gives you this kind of from start to finish approach, and I would recommend that as well.
Thank you. The next question, is AAA more relaxing compared to indies, or is it the opposite?
It is, of course, very subjective because it depends on what indie is and also what work environment you're in, of course. I can say that in especially large companies, you of course have a bigger teams, and that's more relaxed. It's difficult to say. I would say, like, what do you mean by relaxed work environment? So in both areas, you have to get a game done. For indie, it might be that there is more of this adventure rides because uses a small team that hobbyists that try to make something happen. While in bigger companies, there's more regulation. It's more like a regular job. If you call that more relaxed, maybe then this is the answer. But yeah, you would have to clarify a bit on what relaxing means here, I guess.
Okay, thank you. The next question is, do you schedule focus factor time? In our company, we plan like 10 to 15% of time. This depends on the daily activities.
Yeah, it's a thing. It's something that has been tried, and some projects do it, some projects don't do it. It's basically what the team wants. And I had projects where there was a thing like, I don't know, a meeting-free Tuesday or something like that, focus time, basically, where you say this is time dedicated to really go down that rabbit hole, really focus on what's going on. And nobody should book meetings there. There should be non-distracted work. That's possible. In general, if you need focus time, just communicate it to the team usually. Say like, hey, for the next 2 days, I'm not available, or please do not disturb. So for anything very important, you can contact me. But if you just want to have a random question, please hold them off 2 days, and then I'll be back. That's totally fine. Yeah.
Okay, thank you. The next question is it too late to start being a game dev in your late 20s?
It's never too late to do anything, right? No, so why not? I mean, you start where everyone else starts as well, and from there you go on. And to be honest, you're still in your 20s. It's you're young. Do whatever you like to do. No, it's all good. You can start it, and it doesn't matter what age you have. It's just what you can do. And so go ahead. And if you're interested in that, do it.
Yeah, exactly. The next question is, do you guys play the games after they're finished?
Yeah, it depends. I mean, there are people, let's be honest, there are people that are in the team. I mean, we have big teams that say the game I develop is not really the game I would personally like to play. I'm interested in developing it, but I might not be interested in playing it. That's totally valid approach to the game dev. For me personally, it was with Anno 1800. I was a huge Anno fan for all my life. I really was happy to be able to work on that Anno game. So I also poured in hundreds of hours after release. But it's not a necessity. But of course, it's fun, especially if you work on bigger titles. You don't often see all that is part of the game, and then you can just lay back, enjoy the game, and you'll be like, oh wow, I didn't know we had I don't know, fishing in the game or something like that. Yeah.
Okay, thank you. The next question is, have you worked with the Ubi art engine, and if so, how does programming work with it?
I would not be like Ubi Art Engine. First thing is I'm a programmer. I'm not an artist, so I'm not sure how to answer that. And the other thing is I'm not aware. Like I'm not aware of the term. I wouldn't know what the Ubisoft art. Maybe you can.
But
help
maybe
me.
you can elaborate on how the programmers are working together with the artists and
Yes,
how
of course.
this is.
So I think, for example, animation programming is usually a topic where both world meets a lot, and it's usually the engine provides certain ways on how to set up animations, how to set up our assets, and we have to make sure that we read that data properly. So they usually still work in their own tool sets that are industry standard for them. And then they bring this into the engine, and there we try to connect to each other. And sometimes they need certain features, and then we try to develop them. But yeah, it's usually inside the engine where we connect.
Okay, the next question is a question that I can answer because it's, are there any internship opportunities at Ubisoft? And yes, so all open positions, including internship opportunities, can be found on our careers page. So I don't know where you're from or for which studio this would be interesting for you, but you can in general find all open positions, including internships, on our careers page. And the next question for you is, can a software engineer be a game dev, or is it too different?
No, absolutely not. I mean, I also, if you remember that slide I posted with a machine versus player, I would say the player is more game dev-y, while if that's a word, and the machine part is more what classic software engineering is like. So topics for a good software architecture and optimization and those topics that are classic software development topics, they are of course needed in game development as well. And I always think that if you are a solid software engineer and you're interested in games, you can just specialize in that and do the things that we talked about, and then you become a game dev by that.
Okay. The next question. So we already talked about the bachelor in computer science, but maybe there are other ways, because the question is, what are the best courses to start with at college or university level if you are just starting out? Is there a specific college degree to go for?
I won't recommend like a specific degree, because I would not even know all the details of that. So to be able to do that, what I can say is, of course, we have, I think, two different areas. So the one would be game-specific studies, and the other would be like classic software engineering or IT, or no, not IT, but software engineering. I think computer science is what's it called internationally. This is always a great start. It teaches you a lot of good concepts and theory and basics. It depends on what you want to do exactly. Like software engineering or computer science could be a very good starting point if you say I want to start studying. Then the game dev studies are also good. There are private opportunities. There are also public opportunities. At least that's the case in Germany. I'm not sure about across the globe, but all of them are valid. For me, the most important thing to get started is, like I said, get involved with the community. Get this game development mindset and be like, I'm a game developer now and I want to develop games, and do it. Try to do it as much as you can. That's the most important thing.
Okay, thank you. The next question is, what is the major factor that you take into consideration when choosing a game engine? I don't know if you can...
Yeah, well, of course. I mean, let's say, there are engines that are more simple than others, and simple does not mean bad. It's more, they are easier to use. They are designed for quick iterations, for prototyping. So that might be a consideration. So if you prototype a game, we might not want to do this in a very sophisticated big engine like Snowdrop. Sometimes, of course, you could do it, but maybe it's easier to have a smaller program for that to develop. So that would be definitely a consideration. Then the genre you do would be something where you'd be like, what engine might fit my needs the best. That this is usually like it's decided.
Okay, the next question is, does Ubisoft allow you all to do internal game jams like Double Fine to break up the grind and stimulate creativity?
It's a possibility, of course, to have game jams. It's something that has been done in the past. It's always interesting to bring the team together and also have the experts find some innovation. Or it's also, to be honest, a very good team building mechanic, right? To give people the room to be creative together. So yeah, that's definitely a thing from time to time that happens. Although we usually are focused on the projects we have, but yeah, it's a topic that can be done if the team desires so.
Okay. The next question is, as a video game developer, how do you deal with the pressure from the gaming community?
Yeah, that's of course always a big topic. How to do that? So we are not blind. We're not isolated. We do see critical comments from time to time. For me personally, as a developer, I focus on the positive feedback we receive. First of all, it's a personal achievement. So regardless of what others say, you can be proud of what we did. And then I look back at the game and I see the trailers and all the things that we built, and it just makes you like very happy and proud. And then you have to come up or develop some kind of natural filter for certain kinds of topics, comments we find online. That's not just for game dev. That's, I guess, for social media in general. And of course, it's always better if people are wholesome and everyone's happy. But yeah, that's the internet. So there are a lot of different opinions, and that's okay. And I try to focus on the most positive ones.
That's very good. Okay, then the next two questions are kind of similar. I will read them both because they're both focusing on the portfolio. So the first question is, other than examples of our programming in making small games, but could it also be a good idea to start working on your own game engine to use examples for our skills to send to potential employers? And the other question is, what would be good gameplay programmer portfolio projects for you?
So, okay, cool. Yeah.
All around portfolios.
Yeah, I get it. So for the first question, it's quite simple. You would look for a position of an engine programmer. That would not be a gameplay programming, as we talked about today, but it will be engine programming. And for that, it's clearly the best way is to build your own engine. But it will teach you how to work on low-level programming. But it will not teach you how to create features for a game. So that's really different topics. Like you saw, the engine was on the very left, while the gameplay was on the very right, where there was machine versus player. It's totally valid position that is required in the industry. It's not gameplay programming, it's engine programming, and building engines for that is the thing to do. So that's, go ahead, do that, that's good. And for the portfolio projects, I try to come up with some ideas. I don't have this one example you should build. But it's usually try to think of a small game you have, maybe just a mechanic, scale it down even to 50%, and then try to develop that. So let it be like a small factory game, like where you have some production, like Anno, for example. You build a very, very stripped down version of Anno. If you can do that, that's a really good portfolio project. And don't care about the art, just about the logic that happens, the distribution of goods and whatnot. Or you have a combat mechanic that you want to do. Maybe you have one simple NPC, the player and the weapon, and you can do something that hasn't been done before with that weapon, or just shows that you can have nice combat with that. Yeah, this is a tricky topic to get right, but what I mean by that is scale it down and find one mechanic and show off that you can implement that. And that's important.
Okay, thank you. The next question was already answered at the very beginning of your presentation, but maybe you can just say again, what games did you specifically work on? Yeah, so
at Ubisoft here, I worked on Avatar: Frontiers of Pandora, which came out last December. Before that, I worked on Anno 1800. And before, I also developed an indie game that I published. And yeah, before that, it was studies. But those are the two major games I worked at Ubisoft, plus the indie title. Yeah. That was it.
Thank you. The next question is, if you worked as a freelancer at some point, and if you think that it was worth it, or should someone get employed as soon as possible?
So I personally never worked as a freelancer in my life. I always were part of a full team and employed. But of course, it's something you can do. If it comes with ups and downs, it's not just specific to programming. Freelancers, I think usually they earn a bit more because they don't have the job security. At the same time, they also have to make sure they have the network and whatnot. So doing freelancing stuff can be, if it's the thing you want to do, you can do it. But I wouldn't say there's a better or worse in that approach. It has its pros and cons, and it's very individual on what you prefer, I guess.
Okay, thank you. The next question is, do you have a favorite thing that you like to code, like a state machine or something?
Yeah, I mean, state machine. Yeah, and so I don't have this specific feature. What I really enjoy, like I said, is anything that is visible to the player. So the closer I can get to the experience, the better. Let it be camera movements or anything that is where you play the game and you feel like, oh, that's nicely done. If I'm able to achieve that, then I'm a happy programmer. So yeah, that's I try to be as close to the player as I can, but it's not bound to any specific mechanic or topic. Yeah.
Okay, thank you. The next question, you touched upon this as well during your presentation, but maybe very briefly. Do you think one day AI, so I think it's about generative AI, will reach a huge level where it maybe will replace some of the jobs? Or
yeah. I will keep it brief. We're not there yet. If we ever will be there, I doubt it personally for several reasons. But mainly we should consider it right now as a tool and not just as some intelligence being. I think there is a lot of misunderstanding around this topic, and often things are presented as much more capable that they are. So if you have a text generating AI, it cannot think. It might be able to generate text that you think might be true, but there's no thinking behind that. So be aware of that.
Okay, thank you. The next question is, what are your thoughts about on-site versus remote positions in terms of moral and team spirit?
Yeah, again, this is a very subjective topic. I mean, there's no right or wrong. Everyone has different needs. For me personally, I enjoy both working at home and in the office. I love to get in contact with my colleagues. I enjoy the small conversations in between. At the same time, I also enjoy just getting up, being in the office right away, and being on my own at home. That's also great. There's no preference. In general, I also think that it's good to see your teams from time to time. So but again, this is very subjective, and everyone has a different opinion on that.
Okay, thank you. The next question, I'm not sure if this is too much into the art direction, but maybe you have an opinion on that. So when working with artists, do you rank concept art design choices based off its quality of artwork or more so on perceived playability? The person asked because they are a video game concept artist.
Ah, there you go. Yeah, I'm not in a position to answer that, to be honest. Like, I could answer it, but I would not know how to do it. That's an art direction question, so I've never been in that position to decide this, so I'm sorry I can't answer that.
Okay. I think for now, these are all the topic relevant questions that pop up in the chat for me. So maybe 1, 2, 3, if there are more questions on gameplay programming, questions to Torsten about his career, the things that he's most proud of, or whatever you want to know about gameplay programming, drop it in the chat now.
Your last chance.
Your last chance.
Also, big thank you to Katarina for our amazing host tonight. So also give a bit of a shout out and love to her. And I really appreciate all the questions. It was a lot of questions, I feel, so that was great. I hope you took something from it. And if we don't have, maybe we have some more questions. Otherwise, thanks already.
Okay, I think there's another question, but that's like a very we cannot really answer that question kind of thing. But how many programmers are on a team?
Yeah, it's something that I don't know actually. I don't have the number, so I would not be able to share that. But it's large scale teams we have here. So yeah, that's what we can say.
A lot.
Yeah.
Enough.
Yeah.
Okay, then yes, I think we reached the end of the stream. Thanks a lot, Torsten, for your presentation, for answering all the questions. Thanks to you for being part of the stream, for engaging, asking questions. I really hope you learned something and found it interesting. I want to thank the team, Jule for the streaming magic, Stefan for helping with organization, and Basti and David for the chat moderation. And with that, I wish you all a great rest of the week, and we see you next time. Bye.
Bye, guys.